All right, so a couple of things to talk about before we get into today's lesson. As this is our first day of e-learning, I just want to remind you about some expectations during this break from school. You need to make sure that you have all of your notifications turned on. So if you go to our Schoology homepage and in the upper right-hand corner, you'll see a notifications. And so you can do this for our course. You can choose the things that you want to have on and then do that for your other courses as well. And ideally you have the Schoology app. And so you'll get alerts on your phone letting you know when things are ready for you to work on and keeping up with all the different things. Within our Schoology page, if you click on the calendar over to the right, you'll be able to see a list of what's expected from you each day. So here's a quick screen grab of our page. So over to the right, you'll have your calendar. And if you were to click on one of those, it'll tell you exactly what order things are supposed to be done in and the things that you need to complete versus the things, anything that is optional will be listed as optional. If it does not say optional, it is something you need to do. So today, you're going to watch this video, which you're already doing, apply your learning, page 16, check your answers, and then complete the Schoology assignment. All right, more with E. So recall, what is pie? Other than pie being a delicious dessert, P-I-E, pie itself is 3.14159.265 ... And it is the ratio, so the comparison of the circumference of a circle to the diameter. And what's important here is that pi is a number that we call transcendental because it goes on forever. It does not repeat. It does not have any patterns. So E is in that transcendental same family. E, remember, was that limit as n goes to infinity. Okay, we looked at that building the other day. So E is really just a number approximately 2.71828. Okay, and it will go on forever. But you do have an E button on your calculator. We're going to use the function f of x equals e to the x. We again have an exponential because we have a variable in the exponent. And since e is 2-ish, right, between 2 and 3, this would be an exponential growth. So everything we know about our exponential growth is going to still apply when we have e as our base. So key features of this parent in particular, the one with e. We're still going to go through the point 0, 1. We're still going to go through the point 1 base, but this time our base is e. So 0, 1, 1, 1, 2.7. We're going to have our horizontal asymptote at y equals 0. That hasn't changed. And our overall curvature of this graph is an exponential growth model. Our domain here is going to be from negative infinity to infinity, and our range is going to be as close to 0 as possible without touching it all the way up to infinity. So again, fits our exponential growth model that we are used to working with. What ends up being interesting is that when we start talking about that continuously compounded interest, so not just daily, not just monthly, not just monthly, not just daily, not just by the hour, by the second, by the millisecond, we're talking continuously as often as possible. So the n number of compounds is infinity in our equation from before. A then is going to be the output or the end amount. T is the input that relates something to time. P is going to be the principal again, so the amount that we have at the beginning. So remember, this is our initial amount when t is 0. R is going to be just what we know it to be, is our rate. And again, we're going to want it to be, we're going to want it to be as a decimal. And then E is 2.71828 ... But really E is just the button on our calculator. We'll use that as our base. All right, so comparing accounts. You and your friend each have accounts that earn annual interest compounded continuously. As soon as you hear that word continuously, you should be thinking of that PERT equation. The balance A in dollars of your account after T years is modeled with the equation below. So this is your account, and your friend, their account is over here on this graph. So if we look, your amount is equal to 4,500 e to the 0.04 t. This is your friend's amount, which we can see is an exponential growth because of that continuous compounding. Information from your account, your P, your principal, would have been 4,500. So good job having $4,500 in your account. And your R is this 0.04, which really would have been a 4% rate, right? So if we need to find the R by dividing by 100, then once we know the R, we could multiply by 100 to figure out the percent. From your friend's account, well, capital P is supposed to be the initial amount. So at time 0, your friend had only $4,000 to put in. And then R, can we figure out the rate from this? Doesn't look like it. So this R is going to be some sort of a mystery. There are ways that you could find it using your calculator, using a regression, but we're not going to worry about it for right now. Which of you invested more initially? Me. I invested more. 4,500 is greater than 4,000. Which one of you has more money after 10 years? Well, your friend, we can read theirs after 10 years pretty easily from their graph. So 8, so we're counting by 2s. 2, 4, 6, 8, 10. So this would be 10 years. Looks like if this was 6,000, this would be 7,000. So maybe like a little bit more than 7,000. For you, we're going to need to figure out what was your amount after 10 years. So we're going to put in a 10 for time t. So go ahead and go to your calculator. We're going to type in 4,500. Our E button is right here. Okay, you can also use this one, but then you need to press the caret. So I think this e to the x is going to be easier. So we're just going to do second natural log. E, if you have the older version, make sure you open your parentheses and do 0.04 times 10 and then close your parentheses. If you have the version that I have, you don't have to worry about that. Looks like we have $6,700, so $6,713.21. 6, 7, 13, 21, whereas your friend had something definitely over 7,000. In which case, who had more money after 10 years? Your friend did. Okay. Approximately when? Remember, when means we're looking for a time. So when will your account be equal to 15,000? So I'm going to say 15,000 is equal to 4,500 e to the 0.04 t. So if you remember, this is the one where we're going to use our graphing calculator to do a little bit of work. We're going to go to our y equals. We're going to make sure nothing is typed in. We're going to let y1 be equal to 15,000. We're going to let y2 be equal to 4,500 e to the 0.04. Remember t, we're just going to use x. And then instead of pressing graph right away, we're going to think about our window. So we know that we want to talk about something with time 0. We know that after 10 years, I had 6,700. So I'm going to maybe make this like 35 years and we'll just see what happens. Counting by ones is fine. I started with 4,500 in my account. Okay, so that's my lowest amount that's in my account. And I want to know what's going on or when I'm going to be at 15,000. So I'm going to make this upper level maybe 16,000 and we'll see what happens. Instead of counting by ones, I'm going to count by thousands. Okay, and let's go ahead and press graph. There's my $15,000 mark. And I'm trying to figure out when do I reach that? Oh, it's coming in. Ooh, crossing. So somewhere right here, I want to find that point. I can use the trace intersect feature, or I can go to my table, second table, and figure out when do I cross over. Well, this is going to take a while. when do I cross over that 15,000 threshold? So I can keep scrolling. You can also type in your number if you would like. So we're getting bigger and bigger and bigger. Getting closer. 11,000, 12,000, 13, 14, 15. Uh-oh. My calculator's going too fast. I pressed too many times. Somewhere between year 30 and 31. Hold on. Okay, sorry about that. Calculator got out of control. So here we are. 14,000 versus 15,000 happens between year 30 and year 31. So year 30, which means that right now is 2020. So I will have $15,000 in the year 2050. All right, so last week in our warm-up, we had you look up different interest rates back on page 9. What we're going to have you do right now is choose a college that you like and look up their annual tuition. So annual tuition would be for a year. If they list it as a semester, you're going to have to multiply that by 2. You're going to write down what college you chose, the annual tuition, and then multiply that number by 4 because on average, most students graduate in 4 years of college. It says we'll revisit this before spring break. I'm going to say we'll revisit this at some point when we do more application problems of exponential growth. In the meantime, jump on the Schoology discussion if you have any questions, or feel free to send a message to your teacher.